Here's a belief so obvious most people have never questioned it. Intelligence lives in a brain. No brain, no intelligence. It seems airtight, and it's wrong. And ants are proof. We need to agree on what intelligence actually means, because this is where the myth starts. Most definitions point to the same things: the ability to learn, to adapt, to solve novel problems, and to optimise behaviour towards a goal. We typically assume this requires a central nervous system, a brain that receives information, processes it, and decides what to do next. That assumption shapes everything: medicine, AI, even our legal definitions of sentience. But here's the thing: it was built around animals like us, vertebrates, creatures with centralised nervous systems. When researchers started studying colonial insects in earnest in the 1970s, they found something that didn't fit the model. Ants were doing things that required intelligence. By every functional definition, with no central processor, no brain that could account for colony-level behaviour, something else was happening. In the 1980s, ethologist Jean-Louis Deneubourg at the Free University of Brussels ran a deceptively simple experiment. He presented ant colonies with a two-bridge maze, a short route and a long route to a food source. He wanted to know which path they'd use. Early on, chaos. Ants took both paths seemingly at random. No coordination, no strategy. But then something began to emerge. Ants leave pheromone trails when they find food. The ants on the shorter path return faster, meaning they reinforced their trail more frequently. More pheromones attracted more ants. More ants deposited more pheromones. Within 20 minutes, almost the entire colony had converged on the optimal route. The longer path simply faded. No ant decided this. No ant surveyed the maze and calculated distances. The optimal solution emerged from thousands of individuals, each following one simple rule: follow stronger trails. Reinforce them when you find food. Scientists call this stigmergy, indirect coordination through environmental cues. It is, in effect, distributed problem solving, and it works. But is that intelligence, or just a sophisticated reflex? That's the skeptic's objection, and it's a fair one. Following pheromone trails could be pure mechanism, no different from a thermostat responding to temperature. So let's push further. Ant colonies practice medicine. When an ant is infected with a fungal pathogen, healthy nestmates detect it and actively administer formic acid, an antifungal compound, to the infected individual. Studies from the University of Helsinki found this treatment increased survival rates by over 90%. The colony diagnosed a problem and responded with a targeted solution. Ant colonies manage resources. Fire ant colonies change their foraging behaviour based on food scarcity, weather, and colony need, dynamically reallocating workers between tasks without any supervisor issuing instructions. And perhaps most remarkably, ant colonies learn, not individual ants, colonies. Researchers at the University of Arizona found that temnothorax colonies improved their nest site selection over successive trials, making better decisions faster. The colony as a unit remembered. Even as individual ants, which live only weeks, died and were replaced. The individual ant is not intelligent. The colony demonstrably is. Here's where this gets genuinely strange, because what I've described isn't just a curiosity about insects. It forced scientists to rethink what a brain is, and whether consciousness might work the same way. We'll get to that. But first, if you want to know where myths actually come from, this channel is the place. The concept that explains all of this is called emergent behaviour. It describes how complex, intelligent-seeming outcomes arise from many simple agents, each following simple local rules. With no central controller, no plan, no blueprint. The colony is the brain. The ants are the neurons. This isn't metaphor. The parallels are structural. Individual neurons in your brain don't know what you're thinking. They fire or they don't, based on electrochemical signals from neighbouring neurons. Your consciousness, your intelligence, emerges from billions of these simple interactions. Ant colonies work the same way. Pheromones are the electrochemical signals. Ants are the neurons. The colony-level behaviour, foraging strategy, disease management, nest architecture is the emergent thought. This realisation didn't just change biology, it changed computer science. In the 1990s, Italian researchers Marco Dorigo and Luca Gambardella formalised what they called ant colony optimisation, a family of algorithms directly modelled on the ant foraging behaviour. You use the results of those algorithms every day. They underpin modern logistics routing, the system that decides how parcels move through distribution networks. They're used in network traffic routing, telecommunications, drug discovery. The algorithm that helps Google Maps find your fastest route home has lineage in a Belgian researcher watching ants cross a cardboard bridge. More recently, military researchers have studied ant swarm principles for autonomous drone coordination. The same emergent logic, local rules producing global intelligence, now governs some of the most sophisticated AI systems on Earth. We didn't invent swarm intelligence. We discovered it in a colony that's been running the same algorithm for 130 million years. So back to the myth. Does intelligence require a brain? The honest answer is, it depends on what you mean by brain. If you mean a centralised nervous system, a single organ that processes information and issues commands, then no. Ant colonies demonstrate unambiguously that intelligence can be distributed, decentralised, emergent. But if you mean a system that receives information, adapts to it, learns from it, and optimises behaviour towards a goal, then ant colonies have one. It's just not located where we expected. The myth isn't that ants are intelligent. The myth is that we ever understood what intelligence actually is. Fact or fiction? The idea that ants are just instinct-driven automatons? Firmly fiction. The idea that a colony of ants constitutes one of the most elegant information processing systems on the planet? That one's fact. If that changed how you think about intelligence, there's a lot more where that came from. Every video on this channel starts with a belief most people have never questioned. Subscribe and let's keep pulling on the threads.